Leetcode 347 top k frequent elements. It is a medium type problem and it requires understanding of both arrays and dictionaries if we want to have an optimal or efficient approach. And then we will need to use dictionaries, and we don't really need to use anything more fancy, like for example greedy approach or dynamic programming like in other medium type problems. So this might be one of the easier mediums out there. And here is the description. Given an integer array called nums and an integer k. So two inputs. First, this array of integers, which can be both negative and positive, but we don't care about this. And of course, can be duplicated because we want those that are duplicated the most. We add top k frequent elements and an integer k. Our task is to return k most frequent elements. Yeah, so certain elements will be duplicated, at least in some test cases, and the ones that are duplicated the most, for example, if 5 appears 10 times and no other number appears that many times, that will be our most frequent number here. Yeah, and for example, the next one could be 8, which appears 2 times. And we want to have k most frequent numbers. And so not the frequencies, the frequencies we can forget about them, or we don't have to return them at any point, just the original numbers, but the ones that are repeated the most, and k of them. Yeah, and the next thing is that you may return the answer in any order, meaning that when we return, we don't have to return them from the most frequent to the least frequent. Yeah, we can return them in any order whatsoever, which makes it a little bit easier, but in the approach that I will be showing, it doesn't matter really. So we will return them in a proper order. And here is an example just to visualize and verify our understanding of the problem. And we have 1 repeated 3 times, then 2 repeated 2 times, and 3 repeated 1 time. And of course, the number which is repeated the most, our most frequent number, is 1. And it is here in the output. And then the second most repeated number is 2. And that's our second number. And the length of the output is this k. Yeah, so the output is a list of integers and the input is list of integers. The first input, the second is just integer, and that's it. The second example is a single element, like an array or a list that has a single element 1, and k is also equal to 1, and then the output is that same element, meaning that the output and the input are the same, which can also be the case. Yeah, so it could be the case that none of the elements are repeated. That doesn't have to be the case that at least one is repeated or something like this. Yeah, so we have to take care of all the cases and make the answer flexible. And the next thing is it is guaranteed that the answer is unique, and also a follow-up. Your algorithm's time complexity must be better than O(n) log n, where n is the array's size. Yeah, and of course, insertion to dictionaries as well as lookup cost O(1). So to create a histogram or a counter based on that input called nums using dictionaries would cost us O(n). Yeah, and this would be the only operation which will be compute intensive. Yeah, and that's more or less it. And now we can copy this and discuss the solution in greater detail to show you what exactly I mean. But you can already think about using dictionaries for finding frequencies. And the idea is the following: create a counter, dictionary based, where keys are the numbers and values are the frequencies. And that's it. And of course, in Python, we have that advantage that such data structure already exists, is part of the language itself. So we don't have to build it ourselves, but to build it using dictionary, it's not especially difficult. So you can also try to build it from scratch using Berdict. But here we will use counters. It's a part of the language, and it should whatever is already included in the language should be taken advantage of whenever you try to solve a problem, especially algorithmic one, to not make it more complicated than necessary. Yeah, so this thing, a counter, exists in Python. Yeah. Python. And besides the fact that it will build this dictionary with keys and values, they will also be sorted already. So then the second step will be to create buckets, because frequency can be repeated. Yeah, so here each of this number is repeated a different amount of times. Yeah, each of elements has or each of numbers have a different frequency, but it could also be the case that, for example, two numbers have the same frequency. And so the next step will be to create buckets where each bucket represents different frequency, and multiple numbers can be stored in the same bucket. And of course, the most extreme example of that would be if all the numbers were repeated the same amount of time, then we would have just a single bucket. Yeah? And in this case, no matter what the k is, if the k is more than 0, we have to return everything just without the duplications. And then just return k numbers by going through the buckets in sorted manner. Yeah, so we'll try to think about a way in which we will not have to resort the buckets anymore. We will just create them in sorted way, and we'll insert in such a way that the order will be preserved, so we don't have to waste time on resorting, and the only compute intensive operation will be actually to create the counter. Yeah, and all of this should be cheap, the last 2 points. And the numbers here which we'll return them in unique manner, so no number will be duplicated. And that's the whole strategy. So now let's try to do it on this example. And first we would have a counter. So as I said, it is part of Python, so we don't really have to worry about how it works internally, but I think it's still a good idea to create it on your own at least one time, so you learn how it works. Yeah, and the keys are the numbers, the values are the frequencies, and that's it for this example. So that's the first step. The second step is to create the buckets. And we will create the buckets using a 2D list. Which will have as many elements as the input list, and each element will be an empty list. And so we have 3, 6, 6, so 1 too much, 1 too many, and that's it. Yeah, so those will be our buckets. And because the most extreme case is there are like two opposite extremes. First is where each number is repeated different amount of times, and second extreme is that all numbers are repeated the same amount of time, but at most we will have as many elements as in the input array. Yeah, so if we create already this list of lists with empty lists, and there will be as many elements as there are here, then for sure we can be one more, because we will not start from 0. Yeah, so this one will be left empty to not confuse ourselves. Yeah, and the index will represent the frequency. Index of the bucket is the frequency from the counter. And so let's draw indices as well. 2, 3, 4, 5, and 6. Yeah, and we go one by one. And the frequency 3 goes to bucket on index 3. And we enter the number 1 here. And then we go like this. And we go like this. And as you can see, each time when we insert, we mapped already the indices to the frequencies, so we will not have to resort anything. So the insertion should be cheap. And this is 2 and this is 3. Like this. And that's it. And now we simply go from, let's copy this again, not confuse you. Yeah. And the next stage is to go from right to left, because they're already sorted, and gather k numbers. Go from right to left and gather k numbers, and that's it, and that's our output. Yeah, so here is empty. We cannot take anything from here. Here is also empty. It's also empty. The first number that we can take is 1, and the second 2, and that's already our k, since k is 2, and that's the final answer. And that's it. Okay, so now let's translate it to Python. We will use the counter. Then we will create the buckets from empty lists for I in range. Let's get the m as the length of the input, and range is n plus 1. And then we go through the buckets, so we can use a list comprehension for that. So number for bucket in buckets. And sorry, before we return, we also have to map them here. So first for number and frequency in counter items, just iterate through it. We add them to appropriate bucket, and we said that the index is the frequency and the value or the element stored under that index will be the original number. And then once we return, we will just go over each bucket and for number in bucket. And we will take k elements from here. And of course, we have to reverse the order. And to go from right to left. That's it. Let's submit. And buckets here. Not bucket. And yes, sorry, not equal, but append. Yeah, because then we'll overwrite the empty list with the number. So append is the correct way to do that. And now let's submit. And we are faster than 50%. Let's see. It can get better. We can try to rewrite this and exit early. And we can do it in the following way. So let's create a separate list for a result and return the result. And for bucket in buckets, reversed. For number in bucket, I will add it to the result. And if the result has already k numbers inside, we can simply return like this. And here, return an empty list. Yeah, just for the sake of completeness, or for the sake of like clean code, but the input, I think, is guaranteed to have at least those k numbers here, so it shouldn't be the case that we ever reach this point. Let's see. If not, then we will have to rewrite. Let's see, like this. And now it's even slower than before. And what if we try to reduce the number of elements in our buckets? So let's make it like this. The max frequency should be the last element. I wonder if we can also just provide the counter. I think yes. And here, instead of n, let's use max frequency. And now let's try to I think not. We will have to use it like this. Sorry, this should be here. Not from the counter itself, but from the values, because then it will get the keys. Let's try. And now we are better than 70%. And let's try resubmitting. And now we beat 90%. And so there was an issue with the buckets being oversized. And we didn't need that many buckets because the last bucket that we will use will be the one which corresponds to the max frequency. So we were on the safe side, but it wasn't optimal enough.